this one, we're given initial velocity of 44 feet per second, and it slows down to a velocity of 32 feet per second over a distance of 114 feet. So that means our initial position is 0, final position would be 114 after it's reached that velocity. For part A, we want to figure out how long does it take. Well, we need to look at two equations, the position and the velocity. So the position function, remember, is 1/2 a times t squared plus initial velocity times t plus initial position. Velocity is just the derivative of that. So if we take the derivative of 1/2 at squared, 2 comes out in front times 1/2, those cancel out. We get a times t. Derivative of initial velocity times t is just initial velocity. So we need to start plugging in what we know into these equations. Our final position is 114. Don't know acceleration. Don't know time. We know initial velocity is 44. Initial position is 0. Over here, final velocity is 32. Acceleration, don't know it. Time, don't know it. Initial velocity, 44. So we have two equations, two variables. What we need to do is solve this one for A, and we can substitute it in here to find out the time. So subtract 44 from both sides. We get -12 equals AT. Divide both sides by T. A equals -12 over T. Then we can substitute that into our other equation. 114 equals 1/2 times -12 over T times T squared plus 44T. So 114 equals, we get a negative value here, 12 over 2, 6. T, 1 over T squared divided by T is T. So we get 114 equals 38T. Divide both sides by 38, we get T equals 3. For part B, we want to know what the acceleration is. Well, we have an equation right here for acceleration. All we have to do is put 3 in there. So A equals -12 divided by 3. So our acceleration is -4, and that would be feet per second squared. Part C asks how long does it take before the bike comes to a complete stop. So from when it started to decelerate until it finally stops, we can figure that out from our velocity equation. Our final velocity in that case would be 0 because this comes to a complete stop. Acceleration is -4 times t, that's what we're trying to figure out how long it takes, plus the initial velocity was 44. So -44 equals -4t, so t equals 11. So it would take 11 seconds to have the bike come to a complete stop. And then the last part, part D, asks how many feet does the bike travel before it comes to a stop? Well, that would be our ending distance, final position. That happens after 11 seconds, so we'd have to put 11 into the position function. So if we put 11 into the equation, now that we have everything, we would have 1/2, let's see, 1/2 times acceleration, so acceleration is -4, so 1/2 times -4 times t squared, so that's 11 squared, plus the initial velocity is 44 times t, which is 11, plus the starting position, is 0. So S of 11 would equal 242 feet.